Welcome to Knowledge Gainer 1M channel. Today our topic is trains. Let us see in the single train case. A train crosses a pole, tree, man or milestone. The distance is the length of the train. A train crosses a platform or bridge or tunnel. The distance is sum of the lengths, that is sum of length of train and either of this. Third one, a train crosses a man standing on a platform. Then the distance is length of the train. Next, double trains. If two trains come in the opposite direction, then the distance is sum of length of the trains and the speed is sum of the speeds. If two trains come in the same direction, then the distance is sum of length of the trains and the speed is difference of the speeds because they are coming in the same direction. Third one, a train crosses a man sitting in another train. Distance is length of the crossing train. If both the trains are moving in the same direction, then speed is difference of speeds, and opposite direction, then speed is sum of speeds. A train crosses a man in the stationary train. Distance is length of the crossing train and speed is speed of the crossing train. Fifth point, a train crosses a man coming in the opposite direction. Then distance is length of the train and speed is sum of the speeds. Sixth one, a train crosses a man going in the same direction. Distance is length of the train and speed is difference of the speeds, that is difference of speeds of train and the man. Here speeds ratio is equal to distance ratio and speeds ratio is inverse of the time ratio. Let us see question number 1. How many seconds will a train 100 meters long running at the speed of 36 km per hour takes to pass a certain pole? We know that speed is distance by time. Here the speed is given in kilometers per hour, but the length of the train is given in meters. So converting the speed into meters, speed is 36 km per hour. Converting this, multiply by 5 by 18. We get the speed as 10 meters per second. Now the time required is 100. That is length of the train by the speed is 10 meters per second, 10 times. So the time required is 10 seconds. Second question, a train 700 meters long is running at the speed of 72 kilometers per hour. If it crosses a tunnel in 1 minute, then the length of the tunnel in meters is. Let the length of the tunnel be x meters. Now the speed. Converting this into meters, 72 into 5 by 18, 4 times, which is equal to 20 meters per second is the speed. Now the time taken is distance by speed. Distance is 700 meters, that is the length of the train plus x. X is the length of the tunnel by the speed is 20, which is equal to 700 plus x by 20 is equal to 1 minute is 60 seconds. So 700 plus x is equal to 60 into 20. From this we get x is equal to 1200 minus 700. So the length of the tunnel x is equal to 500 meters. Third question, a train with 90 kilometers per hour crosses a bridge in 36 seconds. Another train 100 meters shorter crosses the same bridge at 45 kilometers per hour. Find the time taken by the second train to cross the bridge. Here S1 be the speed of the first train, that is 90. Converting this into meters by 18. We get the first train speed as 25 meters per second. Now the speed of the second train be S2, that is 45 into 5 by 18. We get this as 25 by 2 meters per second is the speed of the second train. Now the distance travelled is x plus y. X is length of the train and y is length of the bridge. First case, speed is 25 into time is 36 seconds. We get this as x plus y is equal to 900 meters. T1 is 36, that is time taken by the first train to cross the bridge. Now T2 we should find. T2 is equal to, T is distance by speed. Distance is x minus 100 meters shorter. So x minus 100 plus distance of the bridge by speed is 25 by 2. This can be written as x plus y minus 100 by 25 into 2. In this substitute the value of x plus y, that is 900. 900 minus 100 is 800 by 25 into 2. We get this as 25 ones 32 times. So T2 is equal to 32 into 2, that is 64 seconds. Time taken by the second train, which is 100 meters shorter than the first train, is 64 seconds. Question number 4. Two trains start simultaneously from stations P and Q 500 kilometers apart and meet after 5 hours. If the difference in their speeds is 20 kilometers per hour, find their speeds. Let S1 be the speed of the first train and S2 be the speed of the second train. Now relative speed. Both these are moving in the opposite direction. So the relative speed is S1 plus S2. That is Speed is distance by 10. Distance is 500 kilometers by time is 5. We get this relative speed as 100 kilometers per hour. The difference of the speed is given as 20 kilometers per hour. S1 minus S2 be 20 kilometers per hour. Now we should find the individual speeds. Solving first one and second one, S1 plus S2 and S1 minus S2, we get this as 2S1 is equal to 120, S1 is equal to 60 kilometers per hour. That is the speed of the first train is 60 kilometers. Now 60 plus S2 is equal to 100. So S2 is equal to 40 kilometers per hour. Speed of the second train is 40 kilometers per hour. Fifth question, a train 100 meter long takes 3/5 seconds to cross a man walking at a rate of 6 kilometers per hour in the opposite direction of the train. Find the speed of the train. Let the speed of the train be s and the speed of the man is 6 kilometers per hour. Now the relative speed, as both are moving in the opposite direction, relative speed is sum of the speeds, that is s plus 6 kilometers per hour. Now we should convert this into meters. S plus 6 into 5/18 meters per second. We know that time is equal to distance by speed. Time is given as 3/5 seconds, that is 18/5 seconds. Time is equal to distance by speed. Distance is 100 meters by speed is 5 into s plus 6. 18 goes to the numerator. After cancellation, we get s plus 6 is equal to 100. So the value of s, that is the speed of the train, is 94 kilometers per hour. Question number 6. A train 550 meters long is running with a speed of 55 kilometers per hour. In what time will it pass a man who is walking at 10 kilometers per hour in the same direction in which the train is going? Now we should find the relative speed. As both are moving in the same direction, the relative speed is difference of the speeds, that is 55 minus 10. 45. Converting this into meters per second, 5/18, we get 25/2 meters per second is the relative speed. Now the time taken is distance by speed. Distance is 550, that is the length of the train by speed is 25/2. 2 goes to the numerator. 5 5s, 5 110 times, 5 1s, 5 22 times. We get time is equal to 44 seconds. If you like my explanation, please like, share and subscribe to Knowledge Gainer 1M channel and also share with your friends. Press bell icon to get notified. Question number 7. Two trains are moving in same direction at 50 km per hour and 30 km per hour speed. The faster train crosses a man in slower train in 18 seconds. Find the length of the faster train. As both the trains are moving in the same direction, the relative speed is difference of the speeds. Relative speed is equal to 50 minus 30. That is 20 km per hour is the relative speed. We know that speed is equal to distance by time. We got speed as 20. We should find the length of the faster train. That is distance is equal to speed into time. Speed is in kilometers per hour. Converting this into meters per second. Speed 20 into 5/18 and the time is 18 seconds. So the distance, that is length of the faster train, is 100 meters. So the length of the longer train is 100 meters. 8th question. A train running at 25 km per hour takes 18 seconds to pass a platform. It takes 12 seconds to pass a man walking at 5 km per hour in the opposite direction. Find the length of the train and length of the platform. Now the relative speed of the man and the train is, as both are moving in the opposite direction, the speeds get added. That is 25 plus 5. That is 30 km per hour. Converting this into meters per second, 30 into 5/18. We get this as 25/3 meters per second is the relative speed. Now the distance travelled is d is equal to speed into time. Speed we get it as, now the speed is 25/3 and the time taken is 12 seconds. 4 times. So the distance travelled is 100 meters, which is equal to length of the train. Here it is the length of the train. Now the speed of the train, s is equal to, the speed of the train is given as 25 km per hour. 25 into 5/18. We get this as 125/18 meters per second is the speed of the train. Now the time taken in case of platform is 18 seconds. So the distance is equal to, speed is 125/18 into the time is 18. So the distance is 125 meters. This 125 meters is length of the train plus length of the platform. Now we should find the length of the platform. Now the platform length is 125 minus length of the train is 100. So it is 25 meters is the length of the platform. Ninth question. Two trains starting at same time from two stations 200 kilometers apart and going in the opposite direction cross each other at a distance of 110 kilometers. The ratio of their speeds is. In this problem, we can use a simple trick. The total distance is given as 200 kilometers. Here the distance travelled by the first train is 110 kilometers and now the distance travelled by the second train will be 90 kilometers. That is D1 is to D2 is equal to 110 is to 90. The ratio is 11 is to 9. As distance and speed are directly proportional, S1 is to S2 is equal to 11 is to 9. That is the ratio of the speeds of the train. 10th question. A train passes platform in 16 seconds and a man on platform in 4 seconds. If the length of the train is 100 meters, find the length of the platform. Here the train length is given as L1, that is 100 meters. We should find the length of the platform, that is L2. Keep this as X. We know that speed is equal to distance by time. That is 100 plus X. This is the length of the train plus length of the platform. By the time is 16 seconds. This is speed of the train in case of the platform and this is speed of the train in case of the man. On cancellation, 4 times X is equal to 400 minus 100. Now X is equal to 300 meters. X is the length of the platform. 11th question. Two trains each of length 100 meters moving in the opposite direction cross each other in 8 seconds. If one is moving twice as fast as the other, the speed of the first train is. Let S1 is the speed of the first train and S2 be the speed of the second train. That is S1 is to S2 is equal to X is to 2x. As they are moving in the opposite direction, the speeds gets added. That is X plus 2x is equal to 3x is the relative speed. We know that time is equal to distance by speed. Distance is given as 200 meters by the speed is 3x. That is the relative speed is 3x. The time is given as 8. So 8 is equal to 200 by 3x. We get X is equal to 25 by 3 meters per second. Here X is the speed of the first train. Now the speed of the faster train is 25 by 3 into 2 because the speed of the faster train is 2x. As the speed is given in meters per second, we should convert this into kilometers per hour. Once and 5 times, 6 times, which is equal to 60 kilometers per hour is the speed of the faster train.